right, this is 6th grade Math 5.5. Let's go to page, let me get to the right page. Sorry, page 255 in your book. Okay, key vocabulary. Here we go. We have a rational number. And a rational number, it's on the top of page 255. It's highlighted in yellow. It says a number that can be written as the quotient A over B. In other words, I like to say a number that can be written as a fraction. Okay, that's a rational number. A terminating decimal is a decimal that stops. Terminating means it stops. A repeating decimal is a decimal that, T-H-A-T, repeats. For example, sometimes you could get 0.313131 and it would go on that forever. And we use a thing called bar notation that shows repetitive decimals. So let's take a look at some of them. Write the fraction as a decimal. 5/11ths, and all fractions you guys, are division problems. So another way to say this is 5 divided by 11. And when you were little, you used to be able to say, hey, I can't divide that because 11 won't go into 5. But now we know you can just add a couple decimal places, some zeros on, and you can divide. 11 goes into 5 4 times, which is 44. Subtract, you get 6, bring that down. 11 goes into 65 times, which is 55. Subtract, add another 0, and you have to go until you start seeing a pattern. 11 then goes into 54 times, which is 44. And I don't know about you guys, but I start to see what's happening. We're getting the 60 again and the 5. So the 4, 5 is going to continue to repeat in that pattern. So the answer to this would be 0.45 with the bar notation over the 4 and the 5, showing that it is a repeating decimal. And there's their division doing the same thing that I did. Okay, so 7 divided by 20. In this case, it would look like this: 7 divided by 20. And again, 20 goes into 70 3 times, which is 60. Subtract, and it won't go, bring down, and it goes in there 5 times, and that's 100 exact. So that one stops. So that is 0.35. There is no repeating. That is a terminating decimal, and so we're done with it then. So basically, fractions are just division problems. You just divide them out. It's kind of like a test grade. If you got a paperback from me and you got an 8 out of 25, you want to know what percent that is. And you go and you take a calculator and you divide it. And then that tells you the decimal, and you can write it as a percent. So this is 8 over 25. Gotta find my pen. 8 divided by 25. Add a couple of zeros. 25 goes into 83 times 3/4 is 75. And 50, 25 goes into 50 twice. So it would be 0.32. And that, if I can get it to go, is it. Let me see, I can't get the slide to move. There we go. 1/6 as a decimal, so that would be 1 divided by 6. Add a couple of zeros. 6 goes into 10 once. Subtract 40. 6 goes into 40. Let's see, that's 6 times, which is 36. Subtract. Bring the 0 down. 6, which is 36. Subtract, and look what's going to happen. The 6 is going to continue to repeat. So 0.16, and make sure you only put the line over the 6, because the 6 is the only number that is repeating in that answer. Okay, so the next example says biology. The table lists the mean lengths of 5 species of finches. Order the finch species from shortest to longest. Okay, so let's take a look at these. And what they're doing is some of them are in decimals and some of them are in fractions. So let's go ahead and write them all as decimals so they're easier to put in line. So 5 and 5/8, what I would do on this one right here is that's 5 point something. Well, 5/8 is 5 divided by 8. So you add some decimal points. I added 2 or 3. 8 goes into 56 times, which is 48. Subtract, bring down twice, which is 16. Subtract, bring down. So 5.625. This is already a decimal. 7 divided by 16. 16, well, I don't know how many times. 16 times 5 is 80, so it's got to be 16 times 4 is 64, which is 60, so it's going to be 3. You know, we may be able to, that may be far enough to help us. And this, 3/4 is like 3/4, and 3/4 is 75 cents. So order from shortest. The shortest is this one. That's 1. 25 cents. Then what do we have? 43. This is number 2. This is number 3. This is number 4. And this is number 5. So what I did is I took them all and I put them in decimal form. So let's see. They probably did the same thing. And then they wrote them out. Okay. There's the one on number line. So order the numbers from least to greatest. So let's change this 3/5 to a decimal that's 3 divided by 5. So that's 0.6. 11 divided by 20 goes in there 5 times, which is 100. Subtract, goes in there 5 again, so that's 0.55. This is 2 divided by 3. Oop, that didn't come out very good. 2 divided by 3, because I have to add some decimals. 6, which is 18, 26, which is 18, 20. So that's going to keep repeating. So that's 0.66. The 6 is repeating. And this is like 60. Let's make sure that has 2 decimal places, 2, 2, 2, and 2. So the smallest one is this one, this number 1. This would be number 2. 50. This would be number 3. This would be number 4. And this one would be number 5. There's the second one, there's the third, the fourth. Yep. Okay, they all have a 1 in front of them. They're all, this one's not negative, so that's the greatest one. That's the biggest one. That's the 1, 2, 3. That's the 5th one, because he's got a positive number. 1/8, 1 divided by 8 goes in there once, which is 8, 20, goes in there twice, which is 16, 4, add another 0, goes in there 5. So that's negative 1.125. 3 divided by 7 goes in there 4, which is 28, goes in there twice, which is 14. Nope, yep, goes in there 7, 8. That's enough. Negative 1.428 or so. Negative 1.14 divided by 15 goes in there twice, which is 30. Goes in there 7. 15 times 7 is 5. Carry the 3. 105. Nope, goes in there 6. So about 1.26. These are negatives, right? So the bigger the number in the negative, the smaller it is. So this is number 1. This is number 2. This is number 3. This is number 4. Let's see what we come up with. Okay, there's number 1. See, they don't have a negative on that one. They have a negative there, but there isn't one up there, so that's a typo on their part, so that's wrong. So let's see if I'm right, at least from here. This one, then I said that was number 2, number 3, number 4. Yep, and then according to how they had it. I don't know how it is in the book. Ooh, there's a negative in the book. All right, writing terminating decimals as fraction. Write the decimal as a fraction or mixed number in simplest form. So the way we do that is you say this the correct way. That is not just 0.4. That is 4/10, because the 4 is in the tenths place. So you just write it 4/10, and then you reduce it by dividing by 2, 2/5. Excuse me. This one is -1 and 905 thousandths. So -1 and 905 thousandths. And then, let's see, obviously 5 can go into those, so -1 and 5 goes into 1,200. Using divisibility, I know 5 can go into 905 because it ends in a 5. 181. And I'm going to say that's it. Let's see. That's it. Hey. Rewrite 0.48 as a fraction by first letting x equal 0.48 repeating, or 484848. So, oh, this should have a bar notation over it. Well, this is kind of fun to do. This is not along steps, but it's kind of fun to do. Okay, so what you do is you just say that the number has 2 repeating decimals. So you multiply by 100. So because the 484848 is repeating, there are 2 repeating decimals, and 100 has 2 zeros on it. So you get, you set x equals 0.48, the line over it. You multiply both sides by 100. So you get 100x equals 48.48 with a line over it. So you just move the decimal over 2 places. And since it's repeating, you just keep writing it. Then you divide by 100 to solve for x. Is that right? No, you don't. You subtract x from 100x. I don't know how you do that. Okay, let's start over. Example number 4. We are supposed to write 0.48 repeating as a fraction. So first let x equal 0.48. Okay, so that's what we do first. So let me erase this stuff here. Okay, so this is supposed to have a bar over the top. So the first thing you do is let x equal 0.48, or 0.4848. So you write out a couple of the repeating digits. Okay, you multiply by 10 to the second, or 100, because the number has 2 repeating digits. So if it had 3 repeating digits, we'd multiply by 1,000. So you get 100 equals 48.48, or 48.484848. Okay? Then you subtract x from 100x. So this was the x we're subtracting. And we get 99 equals 48, which drops all of those. Okay? Then we solve for x and simplify. Okay, I'm going to have to look back at the example when we do this. It's going to ask us to do this, so we'll do it together. Okay, so write the decimal. So 62 would be, 0.62 is 62 hundredths. And then we need to reduce that. They're both even, so we can divide them by 2. 31 over 50. Done. -2 and 45 hundredths. We can divide them both by 5 at least. Let's go -2 and 9 twentieths. Yep. Okay, so here we go. Here's our, so it's negative. So the first thing is you have to make x equal 0.7777. We'll just write a couple of them. There is one repeating digit, so we are going to multiply and get by 10. 10x equals 7.7777. We're going to subtract this one from this one. Those are going to cancel. And I'm going to get 7 equals 9x. So 10x minus x, divide by 9. X equals 7/9. Negative 7/9. Because it was negative. Oh my goodness. I don't know how I did that. Okay, let's try this. This is supposed to have a line over it. Okay? So it's the same thing. So the first thing you do is set x equals 0.363636. You write it out a couple of times. You find out how many repeating digits it has. It has 2 repeating digits. So you take both sides times 100. So 100x equals, and by multiplying it just moves the decimal over, 36.3636. Subtract this one. So you're going to get x equals 0.3636. So these would cancel. We'd subtract, you'd have 36 equals 99x. Divide by 99. 36 over 99. 3 can go into both of those, so it would be 12 over 33. 12 over 33. 3 goes into those again. 4/11ths. Okay, you can ask me for help when you get to those. I'll help you do one of those in class if you need it. Okay? All right. 4/11ths. Look, I got it right. Okay, so give those a shot, and we will see you in the next one, 5.6. Bye.